Well, integrity does not end when production stops. A well that is no longer operating can still remain a pathway for pressure, fluids, gas, or contaminants to move between formations.
That is the central regulatory message here. Closure is not just the end of activity. It is a controlled stage of the well life cycle with obligations that continue after operations cease.
The starting point is suspension. A suspended well is temporarily taken offline, but it remains capable of future use or further operations. That means it must be left in a safe condition. The wellhead must be secured, potential flow paths must be isolated, the barriers must be suitable for the expected duration of suspension and the conditions that may exist during that period.
So, suspension is not abandonment by another name.
Correct. Suspension is temporary control. Decommissioning is permanent isolation. That distinction matters because the standard of performance changes.
During suspension, the operator must show that the well remains controlled. During decommissioning, the operator must show that the well has been permanently isolated from the producing reservoir and from other potential flow paths.
Exactly.
The management plan therefore needs to describe how suspension or decommissioning will be carried out, including the materials used to maintain integrity. That includes casing, tubing, mud, cement, and wellhead equipment.
Once the activity moves from temporary suspension to plug and abandonment, the objective becomes permanent isolation. The well must no longer provide a route for movement between formations.
That is where the central well cross section becomes important. Wellhead security, cement plugs, verified barriers, and permanent isolation are not separate ideas. They work together.
Cement plugs and other barrier elements must be placed across appropriate intervals. Their role is to prevent communication between formations and eliminate potential pathways for flow.
But installation alone is not enough.
Exactly. A barrier must be verified. The regulator needs confidence that the barrier has been established effectively, not merely that a procedure was attempted. That verification can include evidence of where the barrier was placed, what materials were used, and whether the barrier meets the intended isolation objective.
In regulatory terms, the question is not, was a plug installed? The question is, does the well remain secure over time?
Long term integrity is the third principle. A permanent barrier must continue to perform under conditions that may exist after abandonment. That requires consideration of pressure, temperature, formation behavior, and material compatibility. It also requires attention to any mechanism that could challenge the barrier over time.
The focus is regulatory, but the technical basis still matters.
It does. The regulator is not asking for engineering detail for its own sake. The regulator is asking for evidence that foreseeable risks have been identified, assessed, and controlled.
That means hazards associated with suspension and decommissioning must be assessed before work begins. The controls must be suitable, and risks must be eliminated or minimized so far as reasonably practicable.
Precisely.
The sequence can be stated clearly: plan the activity, design the barriers, isolate the relevant formations, verify the result, and document the evidence.
That sequence is important because it prevents closure from becoming a purely physical task. It becomes a controlled regulatory process.
Documentation is where many closure obligations become visible. Decommissioning does not mean the operator simply walks away once field activity stops. Records may be required, notifications may be required, monitoring or other post closure obligations may apply, depending on the well, the approval conditions, and the risks identified.
The evidence trail is essential.
It is, the operator needs to retain evidence of what was installed, where barriers were placed, how they were verified, and what condition the well was left in.
That documentation also supports future decision making. If questions arise later, the record must show that the well was closed responsibly, not just that activity ended.
And that connects directly to stewardship.
Yes. Stewardship means recognizing that an abandoned well can remain relevant long after the original operation. Poor abandonment can create legacy risk for groundwater, subsurface formations, land use, and future generations.
The environmental dimension is therefore not an afterthought, it is central to the closure decision. A non operating well can remain a pathway between subsurface formations. Depending on location and construction, that pathway could potentially affect groundwater or other sensitive receptors.
Which is why the strongest approach begins before the well is drilled.
Exactly. The well should be designed for its full life cycle, not only for the productive phase. Abandonment requirements should be considered early, because the final barrier strategy depends on earlier well design choices.
That includes how casing and cement support isolation, how the wellhead can be secured, and how future decommissioning can be verified rather than assumed.
In other words, closure begins as a planning obligation, not as a late stage reaction.
That is the key message for the slide. Permanent barriers must protect people and the environment long after the well is no longer active.
To close, the regulatory sequence is clear: plan, design, isolate, verify, and document.
A well is not successfully decommissioned when the rig leaves. It is successfully decommissioned when reliable barriers are established and long term risks are addressed.
For operators, regulators, and future generations, the objective remains the same: permanent isolation, verified integrity, and responsible closure.